Picking up where I left off, I went a little fast through that part. So, with coal, this focuses on sulfur, the ones emitted directly, sulfur dioxide, suspended solid particles or particulate matter, carbon monoxide, carbon dioxide, soot. Sulfuric is a secondary pollutant that results from this. So, coal is given a lot of the credit for producing these particular pollutants. It also produces nitrogen oxides, volatile organic compounds, lead, mercury, basically all of the above with coal. With vehicles, if you look up here, oh, I hid that, sunlight plus cars equals photochemical smog. Los Angeles is the place to remember when it comes to photochemical smog. Lots of cars, warm temperatures, warm climate, lots of sunlight. This whole thing, UV radiation, causes some chemical reactions. You get ground level ozone, you get some things, different categories of aldehydes, other secondary pollutants like PANs, these things that we'll talk a little bit about later. And I believe they're in the data table I gave you. It gives you a little bit of a rundown on them. But basically, you need to know photochemical smog is pollutants, specifically these two, exposed to sunlight, yields some secondary pollutants or photochemical smog. Here's some of those other ones that I mentioned, PANs, VOCs will lead to that stuff. This is where we were today, but outdoor pollution may be decreased by settling of particles due to gravity, rain and snow, salty sea spray from the ocean, winds, chemical reactions. These things, even though they do clean it up out of the air, they can transfer it to other places. So rain, acid rain, if it ends up in a pond, it can change the pH. Winds can take pollution from one area and push it to somewhere else. And then chemical reactions, even though it might clean up one air pollutant, it might turn into a secondary air pollutant. So these are not always things. They clean it out of the air, but it may lead to problems elsewhere. Outdoor, these are things that increase pollution. So urban buildings trap it. They cut off wind, currents, that type of stuff. Same with hills and mountains. High temperatures, you end up with things like photochemical smog. The grasshopper effect just says that pollution will move from one place to another or hop from one place to another. So just because it's produced in one area doesn't mean that's the only place it affects. It can jump to other cities or areas. Temperature inversion, we'll look over here. Basically, a temperature inversion or thermal inversion is when you get cold air that gets trapped below a warm air. Typically, you have warm air near the surface that's constantly rising, and you get this mixing of air. In this case, you get cold air that's trapped, and this is common in Los Angeles, actually. You get cold air that's trapped beneath warm air. And it's not a bad thing that an inversion layer happens, but if you have a lot of pollution, then this cold air sits here and it doesn't rise and it doesn't circulate. And so you end up with the pollution just sort of getting stuck or trapped here, making for poor air quality. Acid deposition. So acid deposition, we have two categories. You got wet and you have dry. Wet is when sulfur dioxide or nitrogen oxides combine with water in the atmosphere and they come down as an acidic rain. Now, the pH needs to be 5.6 for it to really be considered acid rain. That's why it's considered wet deposition and not always acid rain. Wet deposition doesn't necessarily have to have that pH. It can have a slightly acidic pH. But in order to be categorized as acid rain, it needs to hit that 5.6 number. Dry is when sulfur dioxide or nitrogen oxides are just, they travel in the wind or air currents and then they end up falling to the ground and they might get into soil, they might get into water, and then they combine with water and form the acids and can change the pH of the soil or the water, upsetting living things. So you guys have this here in your textbook, but you have cars, you have the burning of fossil fuels, you have those kind of things getting wind-borne, and they can turn into these things in the air and then come down in rain or snow, or you have the dry deposition, and they can actually turn into salts and ultimately change the pH when they're dissolved in the water. Areas where you see the red is areas where you see there are problems with acid deposition, including lakes and rivers where those things are deposited. Yellow is potential areas because of air pollution where you could possibly get it. And then the green is sensitive soils, areas where this would really have damaging effects on the soils. Acid deposition, because you're breathing it in, it's going to affect, respiratory disorders. Release of toxic metals and leaching of soil nutrients, because it will start to break down rocks, those kind of things. It releases things into the soil that can overwhelm plants. Sometimes it can be toxic to them, that are otherwise trapped in the soil. So the sulfuric acid can break those things down, can lower the pH in aquatic ecosystems. It can do physical damage to trees, to buildings, particularly concrete, stone, those kind of things. With prevention and cleanup, the biggest thing is coal. We need to slow down the use of coal, because this is the biggest contributor, or, use low sulfur coal, which way back we talked about the levels of coal, where we talked about peat, lignite, bituminous, and anthracite. Anthracite is the purest form of coal and has the lowest sulfur, but it's also the most expensive, so we tend to use lower quality coal, which contains a higher level of sulfur. The other thing, natural gas doesn't have the sulfur problem, so relying on that and renewable energy versus coal is a good move. Smokestacks are filtration systems that remove the sulfur dioxide, and then we tax those who add a lot of sulfur. Cleaning up, it's all about neutralizing, but this can bring a whole nother set of problems, like phosphate fertilizers can stimulate algal blooms. So if a lake is acidified, you want to neutralize it. If you use phosphates, it can stimulate algal growth, and then you got a whole nother set of problems on there. So it's just something you got to be careful with. Indoor air pollutants. In developing countries, most of this is associated with things that are burned as a source of fuel to heat water, cook food, heat the home. And you can see wood, charcoal, dung, crop residues, coal, they're all along the same lines of a lot of biofuels, essentially. Obviously, this is a fossil fuel, but was once bio. Greatest risk to low-income populations because they don't really have a choice. In developed countries, indoor pollution is actually a greater threat than outdoor, because we've cleaned up a lot of our ways outdoors. Indoors, we have some remnants of things from way back that are still causing problems, or materials in our homes or at work that we don't even realize are affecting us, but can still be a problem. And you guys have a chart like this, and I gave you something that this has a lot of information on it. It's really pretty difficult to look at, really. But I gave you guys something in your little diagram that shows a house, breaks it down by room, gives you a few little things with some notes attached to it, that goes through some of this stuff similarly, a little more simply. Who's at risk? Young, the elderly, sick, pregnant, if you already have respiratory or heart disorders or problems, smokers, and then factory workers, because they don't necessarily have a choice. Four most dangerous are on the test. You need to know the four most dangerous: tobacco smoke, formaldehyde, radon, and then ultrafine particles. Some other things: pesticide residues, lead particles, old plumbing can release lead particles, lead-based paints, which are older, types of paints, that type of stuff. And then you have mold, mildew, things so simple as like pollen, that type of stuff. Pet dander, all those things are indoor pollutants. Radon, radioactive radon. You do need to know what it is. Sources: uranium decay, found basically in all soils. In some places, it's more highly concentrated, so you're at greater risk of radon potentially coming into your house. It decays after a fairly short period of time, but it's a constant supply of radon. So it'll go away after a while, but it's just constantly coming in if you have a radon problem. Pretty much every home has radon in it. Radon typically comes in through the soil, through the slab of concrete, cracks, that type of thing. The way to get it is you catch it before it comes out of the concrete. You build a ducting system that transfers out to the outside environment so that it doesn't build up in your home, and basements a lot of times are most at risk there. Today, this is the slide that we finished up on, just some of the health issues associated with air pollution. And on to the next video.